Well, while we're waiting, Airman Griggs, you got any questions that we need to go over? Oh, good. Good. You do know that we have the electronic copies as well as the paper copies in the testing lab. You do now. Yeah. All you got to do is go to the file, too. You should have had that as a when you got your sources for Block 7. Well, thank you. Yeah, it's just taking some time, right? Okay, so everything's okay. I'm trying to shove everything in this one little area, and it may or may not work. There we go. I love it. I love it. Oh, just give you this video I'm working on for the next portion for Block 4. My green screen is creating all kinds of problems for me. Why, you ask? It's called... I got a football field in there. And what's the color is the football field? Green. Unless you're Boise State. Then it's blue. But yeah, it's... I don't care who it is. But I'm using sports for comparison. And that first part, it took me forever. I've been playing with it for the last week, trying to get it. But I think I got it now. Hopefully I'll have this all put up online by tomorrow. And then I get to work on my favorite one, which is next. I'm not going to say anything either. Yeah, because 2014's in Block 8. Who was it? Sorry, McCormick. Who was it? Excuse me. Sorry, McCusker. Who was it? Aaron Masses. Hey, welcome. And if you talk, it's push to talk. I thought it was Airman Payne. Maybe not. Okay. Excuse me. Okay, Airman. Man. While everybody's trying to get in here, I'm going to go grab me some more water. I'll be back in a sec. Wow, just trying to get everybody in. First task. Oh. Okay, we got 2. Okay. So how about the others that are you got? Okay. All right, Airman Griggs and Airman Masses, what are your questions that I can help eliminate some of the confusion there for you? No questions? Okay, Griggs? Okay, so do you have a problem if I ask you a few questions? All right, so out of the clocks, or excuse me, let's try this, the timing devices that we were using, and there were 3 of them that we discussed, which one is the most accurate? Cesium, okay, right. What's the least accurate? Okay, we talked about 3 devices in there. Quartz, yes. And what does the quartz utilize to generate a clock? What's it called? Cool. You guys are getting it together there. Now, there were, let me see if I can, I don't want you to see that yet. It's my little, so what's the difference between a primary source and a secondary source? Okay. So who is the keeper of time? Nope. Okay. They're out of all these distribution agency, who is the keeper of time? That is correct. Who's the one that does DoD? No, the first one was BIPM. The second one is, yep, for Department of Defense. Okay, and who does the civilian side? Okay. What are the frequencies that NIST use? Okay. Yeah, it uses HF side of the house. It goes 2.5, 5, 10, 15, and 20. And it also uses the 60K. Believe it or not. So, all right, let's take a look at what causes what causes short-term jitter? Yep. And what do we use to combat that? In other words, what's a corrective measure? Mm-hmm. That is correct. So I'm looking for it for short term. Yes, that is correct. There were 4 types of network synchronization. What are they? Mm-hmm. And one more. Correct. So which one does DoD use? Correct. That is outstanding. Okay. Yeah, you. You gotta be kidding me. Why is it that when I want things to go right, they don't? Why? Yeah. Okay. Okay, so what is the definition for sampling? Ooh. Snag. Okay. Okay. That's the big part. Sequential. All right, what's a frame? Nope. Nope. Not there yet. Not there yet. Not there yet. You're getting there. So what is a frame? I couldn't help, snicker at that one because I'm on the page where it's at and it has boxes. I understand you're drawing a picture in your mind. So a frame consists of a sample. There's a reason why I asked what the heck sample was. So the next one would have been frame. So it's a sample from each channel. So in other words, I'm taking a sample out of that waveform and I'm putting it into a frame. So that way we can figure out where each one of these segments go. It's all about the timing. So what the heck is a non-information bit? Yeah, but what is it? There you go. Yes. In other words, it's not part of the user data. Do you know what user data is? Okay. Now I'm going to get into a little fun stuff here. So let me get to it first before I think the rest of your class is here. Yay. Okay. So with that in mind, shoot, I can't even remember what the heck I was talking about. Oh my goodness. Joggle my memory quick. Okay. And we talked sample. Okay. So sampling is what we do, and that's the reason why I'm pointing it back at, I think it's Airman Masses that said this, that talks about the PCM steps. Okay, using the word PAM, not Peter Pan, but PAM, P-A-M, pulse amplitude modulated pulses, and each one of those are sequential. They're equal in distance, and we take that sample, and what do we do with it? Yeah, there you go. Now, there is this thing called quantization errors. What causes that? Explain true values. That's exactly right. In other words, they're trying to find a place to be put on a quantization table. So you have two different types of tables. What are they? Correct. Yep. Yep. Mm-hmm. Anybody else want to try? We have Airman Boston. We have Airman Tierman. Anybody? Do you want me to explain it? It's a yes or no question. I'm not gonna. We are on PCM steps here, and we are on the uniform quantizing, and he was trying to tell us about non-uniform quantizing. And I said, well, can you explain what is non-uniform quantizing?
I think it's like when if most of your values are going to be rather low, like 3 or 4 volts, you have more values around there, so you can get more accurate, higher resolution.
Okay. Okay, let's take a step back, and if you think about what PCM is doing, it's taking an analog signal and convert it into a digital signal. Well, analog is voice, and if you take a look at most of our voices, we're in that, 300 to 3K average. So that would be kind of low compared to what we're used to seeing, which is the, music, which is going all the way up to possibly 25K. But we use the PCM because it's the easiest form of converting voice into digital and sending it out over the airways. So when we do non-uniform quantizing, we are in this smaller area like you were talking about, but we're doing it for voice. So as you know, Dr. Nyquist came around and said, hey, voice is anywhere from 0 to 4K. And that's where we came up sampling twice the highest frequency. In our case, 4K, is where he came up with. And it made a lot of sense back in those days. So when we do non-uniform quantizing, we're trying to get the general population of voice patterns, and that's where that squishing of the lines in place. And then when you get like someone has a really high voice, you're going to start seeing a lot more quantization errors. And somebody who has that deep vibrato bass voice, you're probably going to get some quantization errors in that too. So yeah, by non-uniform, you're giving it more of a value and not seeing those quantization errors. Granted, you're going to see a lot more quantization errors in uniform quantizing versus non-uniform. So that's where they came up with that and why we use non-uniform. So when we go to the last step is encoding, correct? So how do we get 8 bits out of that? Does anybody know? Nope. Okay, so first of all, let's talk about 8 bits. Everybody knows or should know that you have 1, 2, 4, 8, 16, 32, 64, 128, right? You add all those numbers up, what do you get? That is correct. So if you take a look at the uniform or even non-uniform quantizing table, you have a positive 127 and a negative 127. Okay? You add those two numbers, what do you get? No. Take 127 times 2, and what do you get? Should be 254. Right. So we got 256 that we need to get. That 8th bit is that plus or minus in there. So the first 7 digits in the 8-bit code equals 127, if you were to add them all up. And the last code is where you get the positive and negative on. So that's how they encode it. So what are the 3 steps of quantization? Or excuse me, what are the 3 steps of PCM? Pretty easy. What are they? And? Good. So we got the PCM out of the way. What about frame period? What's a frame period? Definition? Go ahead. Okay. And everybody knows how to do the mathematics behind that, right? Oh. Sorry, McCusker's got this going. Does everybody understand the frame period and how you get frame period? With the mathematical equation, correct? No? Maybe? I don't know. Okay. Let me see if I can... there it is. Okay, so everybody see that? Got a nice little whiteboard in there. It's CRETA. That's what it's called. So if you have frame period, frame FP is equal to 1 over your samples. SAMPLES. So what did Dr. Nyquist say about sampling? Twice your highest frequency. In our case, it was 4K, so it'll be 1 over 8K. And we come out with 1 over 8 should be what? 0.000125 1.25 seconds or 125 microseconds. Remember now, you're dealing on the opposite side of the decimal point. So what's PMSP? What's the definition of PMSP? Okay, so in this case we have, come on, where are you? PMSP is equal to, we have frame period, I'm going to just put FP here, over number of channels to our multiplexer. What's the standard nowadays? What's the standard multiplexer have? How many channels does it have? Okay. What they've said is there is a standard of 24 channels. All right. Now, I have dealt with multiplexers that has 16 channels. So the PMSP is going to be different than something that has 24 channels. So in our case, just to give you an idea, we're going to take this 125 microseconds over 24 channels, and we should get 0.000 1, 2, 3, there's 5, and then should be 5 to 8 seconds, or better known as 5, oh, my crazy writing here, to 8 microseconds. Now, if you take a look at this, you have frame period, which equates to 125 microseconds, and then we have 24 of the samples that we're going to take. So one of these equates to 5.28 microseconds. There's more to that math, but I'm not going to get into it. So you can see from here to here is 125 microseconds, but that one sample taken out of one of the channels is 5.28. So frame period is large when you compare it to pulse modulated sample period. So that's the reason why we got to look at the bottom line on PMSP and looking at those particular channels in that multiplexer. So everything is predicated to the multiplexer's channels. Questions on that? That make it a little bit more clear for everybody. All right. Let me go to the next one. Here we go. What is the difference between a balanced line and a non-balanced line, or an unbalanced line? Okay. Okay. How about the unbalanced? Fantastic. Now, has anybody ever heard about noise canceling headphones?
Yes, I have.
I know you have. Okay. The balanced lines is the same thing as your noise canceling headphones. What it does is it takes the noise outside and reverses it 180. So when it gets put back into your ears section, it eliminates the noise when it puts it from those two phases out. One's out of phase of the other. When they put them back in, it eliminates the noise. That is the same thing. So it's one of those things. They use it for 2 pair lines or 4 pair lines, depending on what's going on with it, compared to cable. You know, twisted pair versus cable depends on what you need it for. So there you go. What is DTE? Not data terminal equipment, but what is it? Give me an example of it. Okay. Anybody? Nobody had. What's that, sir? It's close. It's the computer, if that's what you're referencing. In other words, it is the source and destination. The terminal bit is where everything gets generated to, or is the receiver. That's the end result. How about DCE? What is it? Everything? Yeah, the modem, yes. I'm not going to say yes or no on that because it depends on the industrial standard. In this case, we're just going to go with the modem. You could say that a server is that, but at the same time, what are you doing? A multiplexer could be another one, but let's just keep it simple and go with the modem. So you have a terminal, and then you have the communications. Excuse me, coronavirus. The issue with the modem is you're taking the computer and generating an analog signal that's a representative of the digital signal and sending it out to other pieces of equipment. So let's just go with modem on that one. There are 4 types of transmission media. What are they? Okay. What is DSU? What is a DSU? I could barely hear you. Whoever it was that responded. Okay, and where's it normally located? Okay, normally the DSU and the CSU are in the same box nowadays. Just to give you an idea, AT&T or Verizon or whoever you talk to, for example, if you're having some difficulties getting your, let's just say your internet went out but your phones still work, that's who you're going to talk to. And what they're going to do is they're going to take a look at the DSU or CSU. Big difference between the two. The CSU is on their side. The DSU is on our side. Has anybody taken a look at any of the pictures that are out there for this? You could say no. I'm going to pull this. Yeah. Let me see about getting you this picture up to give you a better idea on the differences between a CSU and a DSU. Let me go big here. I know I saved it. Can you see that? Okay. You notice where the LAN is? This is where all the users are. Here's your router. There's a DSU. CSU is going out to the server farm or whatever you want to talk to. But the DSU is on the customer side. So when AT&T or Verizon, let's try that again. If AT&T or Verizon is checking their system out, the first thing they're going to talk to is the DSU to see they have a line to your service to make sure that everything else is working just fine. Now you can see where Sergeant McCusker, let me narrow this down just a little bit. You can, yeah, McCormick, McCusker. I'm going to start calling you Big Mac. He's Little Mac. So, but you can see where we have two CSUs and DSU boxes. You don't know which side goes where. Whereas, you know, this one, the box on your right here, shows you a little bit better as to what is happening where. So, C is not customer. A lot of people get that wrong. Oh, they see it as CSU and then voila, hey, that's the customer side. No, it's not. The DSU is the customer side. CSU is the actual the server area. Is everybody clear on that one? Kind of crazy. Google is wonderful at times. So if you are having problems, if we're not answering it, you know, to where you understand it, just go to Google, go to images, and it will show you pretty much anything and everything you need to know. All right, so yep, that's the only way I will learn sometimes. So go for it. All right, so the next one coming up. It's kind of sad. I closed it out. Ah, yes. What is so how many ports does an NSM have? What should be the correct answer? What should be the correct answer on this one? There you go. You should look it up in the TO. So you have 4 different types of ports. You got 12 NRZ, you got 6 T1 E1s, you got 6 CDIs, and you got 2 high-speed interfaces, which I like to call HISSIs. So what's the max data rate on the NSM? Yep, that is correct. Now, where should you find that? Yep, correct answer again. Winner, winner, chicken dinner on that one. So, we look at the The Burt's. What are the three things that the Burt's does? In other words, the HST 3000. Okay. What was that? I could barely hear you. Well, yeah, that's what you're looking for is your error that you have on the line. But what's that called? There were, count them, 3 that they... What's that? Okay. Anybody else want to help? All right. Yep, that's one of them, which was the end-to-end as it just described there. What else? That is correct. And that was the errors that you were talking about. Yes. So there is the next step. We're looking at the basic radio picture. There are 3 steps when we talk transmitting the baseband to the distant end. What are they? Okay, yes. When you say mux, demux, okay, modulation is transmit, demodulation is receive. So in this 3 steps, there are modulation, up conversion, and amplification. So where's the oscillator being used in one of those 3? The local oscillator, where's it used at? Which of those 3 steps? Yep. And what does it use to stay on frequency? Yeah, how do I keep the oscillator from drifting? Anybody heard of PLL, phase lock loop? Yeah, phase lock loop. Yeah, just back in when we were talking about the timing jitter. It doesn't correct for long term. However, it helps it along to get everything in sync. You know, bye. No? Okay, bad. I know. Okay, so there are 3 steps when we do the receive path for the basic radio, which is called recover the baseband. So what are the 3 steps? Yep, there you go. There you go for the 3 steps. Do you know what a branch assembly does? Okay. What else? I take it you guys are, since you had a huge discussion on this earlier, kind of got your brains a little bit fried there. Yep. Oh, okay. So, yeah, that one is mainly for your receive side of the house. You also have something called the suppression of harmonics, noise, and it's also a way to find out what your output power is. So you have a transmit and receive type of assembly going. None of it is powered. None of it. So when they talk about branch assembly, it's farther than where your last, if you're in transmit, it's beyond where that last amplification is. And if it's receive, it's everything before you get to that amplification to get the RF out. So when we look at RAGO, what is the whole idea behind RAGO? Fantastic. It has everything to do with transmit or receive. Transmit or receive? Yep, I didn't hear you the first time you cut out on me. So it is receive. So what dictates the frequency, accuracy, and stability of a radio? Yep, that is the one. I'm just running through to take a look. So what's the definition of quality?
How close the received signal?
Yep.
How closely the received signal is up?
Okay, good. Reliability? Well, I'm sorry, I didn't hear you there. No, it's fine. Yeah, so what is reliability? What's the definition of that?
Percentage of system uptime.
Correct.
How often the system's up compared to like all the time, or when it usually the radio link is active in transmitting, or not transmitting, but active and ready to transmit.
Mm-hmm. So in other words, if it's broke, we got problems. The reliability goes down. If, like you were discussing earlier, if let's say your multiplexer goes out, well, your system is down. So the reliability goes down. What's nice about some of the reliability that we have out there is we always have backups. Sometimes you don't even know it if you're a customer. And of course, us maintainers will know at that point. But it just gives you an idea as to how reliable is that equipment. The uptime, as he says, is it working or is it not? That's the big key right there. So what's a performance monitor? You guys were playing with the testers today, correct? Okay, so what is a performance monitor? Okay, so in other words, you have a meter, everything's in the green. What happens if it's not in the green? Hey, you and I are on the same path sometimes. Okay.
You go through the troubleshooting steps.
That is true. That is true. What happens when you have this, the summary alarm is on when you go from standby to operate? The summary alarm, if the summary alarm is in the, I think it's what, yellow? It's been a while. It lights up red? Okay, thank you. Okay, so you flipped it from standby to operate, and the summary alarm is red. Is there a problem? Yep. Okay, what happens if you turn it to standby and it's still red? Solid. Okay, what happens if it blinks? Okay. Yeah, it could. All right. So at this point, it's 4:56. I know you guys are probably pretty tired. Hopefully this helped out. Is there any questions that you want me to answer either now or later so I can be prepared for tomorrow? Your choice. So was there a particular thing you wanted me to go over today or tomorrow? Okay. And I'm trying to figure out what you're saying. You're talking about the front feed versus the rear feed? Okay. All it is just difference of where you're going to channel that RF, either input or output. Is it going to use the rear? Is it going to go straight out the front? You know, what is it going to do? With front feeds, what it's going to do is automatically bounce right off of the dish and transmit and then out. And then in receive, it's going to come from the RF into the dish and then bounce it back into the feed horn. Whereas rear feed, it's got to do what I call a double shot. So it hits the dish, goes into another reflector, and then back into the antenna area through the waveguide. Yeah, and Sergeant McCusker actually, yep. Mm-hmm. Okay. Okay, is there anything else that you want me to quickly go over? And tomorrow we're going to be doing the same thing. We'll go through probably what's left. I'll throw some odd questions in there if just to get a feel if you understand the material. So be prepared tomorrow. Same time, same place. All right. Yeah. So if you guys got questions, please come with them tomorrow. Okay? You're welcome. You're very welcome. We'll see you tomorrow. Signing off. Good night.